Hello everyone. In this video, we are going to deploy a DeepSeek-R1 model. To be specific, a 32 billion model based on Quen 32 billion using Ray and vLLM on a distributed system. So let me clarify, this video is not a fastest way to have your DeepSeek-R1 model running. For that, one can of course straightforward run a small model on Olama. Rather, we are going to see how we can run a larger model on a distributed system. So let me first give you a short intro to Ray. It's an AI compute engine where one can run ML tasks like data processing, training, inference, and in under one unified platform. You can of course run these workloads in a distributed fashion by just using Ray. You don't need to be a distributed system expert here. For our use case, we are specifically going to use Racer. So Racer provide us the HTTP proxy through which we can run our model inference. And here, as you can see, the Racer utilizes the Ray actors. There is much to the theory, so I think that's enough for now. Before we get sleepy, let's start some action. But if you want to learn more about Ray, then I will share some links in the description. So let's get started. I'm assuming that the audience of this video already knows about the Kubernetes and is familiar with Ray also. I am not making a basic tutorial for a Ray or Kubernetes, so this will be a little bit fast. I will also write a blog for this video, but where you can see the details and learn more about a specific topic. Let's get started. Here I am using Azure platform, but you can use any platform that you like. Steps will almost be the same. So our first step is to create the Kubernetes cluster, and we are going to have one CPU node and two GPU node. This here is the resource group that we will be using. I have already created it. So let's create the cluster. This is the VM that we are going to use, and let me show you the configuration of the VM. Here, CPUs are 8 and 32 GB of RAM, and for the GPU node, we are going to use a standard NC4S T4V3. This is a Tesla T4 GPU VMs, and the one that I am using will have one accelerator only. So we will be using two nodes, so total of 32 GB of VRAM will be available to us. And the model that we'll be using is this is our DeepSeek-R1 Distill 32 billion model, which is quantized to 4-bit via AWQ. So I think with a limit to the context length, we will be able to fit our model to our 32 GB of VRAM. Let's wait for our cluster to get created. Great, our cluster is created. Let's now add two GPU node to it. For that, we are going to use the node pool command, and here we are specifying the node count as 2 and both node as type T4V3, which is Tesla T4, each 16 GB of VRAM as we have already seen. And this is the cluster name that we have already created, and we are adding this node to that cluster. Let's wait for it to complete. So now our nodes are added. Let's check the configuration if everything is correct or not. So instead of going to the Azure portal, I am using the K9s. For that, first we need the Kubernetes cluster credentials, and we can get it from the get credential command. Now let's go to the K9s nodes. So here we have two GPU nodes and one CPU node. Let's describe them. And this GPU node, you can see here, there are no GPU as an allocatable resource. Neither in this node nor in this node. And in the CPU node, of course, there is no GPU. So why it is so? Why the GPU nodes are not showing as GPU allocatable sources? This is because we still have to create the configuration for it, and for that we are going to use the kubectl command, and then this is the configuration we are going to apply and hit enter. So let's wait for a minute for it to complete. Okay, let's see again the K9s and describe and the GPU node, and here we have the NVIDIA GPU available finally. Now let's see the other node as well. We have the NVIDIA GPU available here as well. Uh, for our confirmation, let's also see the CPU node. And in the CPU node, there is no GPU as expected. Now our configuration is correct. The next step is to install the KubeRay operator and KubeRay API server. Before doing that, let's create taints for our GPU node. But why we are going to do so? It is because we don't want our GPU resources to get exhausted. Rather, we want other helper resources to be installed in CPU node. So let's get the nodes and apply the taint. We are setting the key as CPU, value to true and no schedule, operator to equal, enter. And then let's apply the same to the second node, enter. And yeah, so let's check if everything is correct. And here we have the taint available, and in the other GPU node, so here as well. Now we are ready to install the KubeRay operator and KubeRay API server. But what are they? Operator acts as a controller for Ray, and KubeRay API server is for our convenience. So instead of using the Kubernetes native API, we can just use the KubeRay API to create the Ray cluster via API endpoint. I'm going to use the Helm for it. So I already added the repo. Let's install the operator first, and now the API server. Okay, so now let's check their status, and they are running. Let me port forward our API server. The server is currently running on 888 port. So let's port forward it. Done. Okay, now let me show you the KubeRay API server documentation. Create the cluster, we first need to create the compute template. Let's look into that first. So compute template basically specifies the resource for the head and worker group like CPU, memory, GPU, and also the toleration. These toleration are needed for us since GPU nodes that we created are tainted. And then this is our cluster API. We will go through the payload once we create the cluster by ourselves. Let's create a compute template then. Before creating the compute template, I remember we first had to create a namespace. So why we are doing so? Because so that all of our Ray related resources are in this namespace. So this is the namespace. Let's just create the compute template now. So we are creating this compute template in the namespace that we just created. And this is the name of the compute template. This will be used for head. We are assigning CPU as 5, memory as 20 GB. Let's hit enter and create it. Done. Now let's create for worker. So rest of the config is same. We are providing GPU here as well. And also here we are also providing the toleration because our GPU nodes are tainted. Let's hit enter and create and done. Now we are ready to create our cluster finally. The namespace is again Ray blog that we created earlier. Let's look into the head group spec. This is the compute template that we created for the head, some default Ray start params, and this image, it is important. So basically this image installs the Ray as well as vLLM to both head and worker. Let me walk you through the code for this image. Uh, hmm. So this actually the vLLM sample that is present in the Ray repository. I have modified it for yes vLLM version 0.65. But then also let's do a quick walkthrough. It uses the fast API server and we are exposing here a version 1 chat completion endpoint for our inference. And here this is the serve application which will be used by the Ray serve, and it is present in here in this model variable. I have also added some extra variable like GPU utilization, which I have set to 95%, and also here a max model length. So this max model length will be helpful since a model is 128K length, and it could happen that our GPU memory cannot accommodate that much KV cache. So we are going to give it as 8K. I think that would be enough for our test. And here is the make file. It just creates the zip of all the files present in this folder. Let's continue our cluster creation. And so this is our worker group, and the worker group has this compute template that we created. And here we are setting replica as 2. So this is because we are going to have two workers with one GPU each, and our model will be sharded among these two workers. The same image that we have just gone through, and also here is an environment variable for Hugging Face Hub token, which will be used to pull our model. Here, this annotation is needed since this exposes 8000 port where the fast API application is running. So I think we are ready to hit enter now. And okay, so no error. Let's see in K9s what is going on. Let's go to the namespace that we just created. And here our nodes are under creation. Let's describe them by pressing D. They are actually pulling the image and it will take some time. So wait for it to complete. Okay, our Ray cluster is now running and it's time to create the serve application. So let us go through the payload. The import path is serve model. This is because the serve.py we have this model variable which is of type serve application, and it will run our fast API server. And then we have the name of our application prefixed to slash default auto scaling config. Now under the deployment, we are keeping the Ray actor options as empty here. This is because whenever we are passing tensor parallelism or pipeline parallelism greater than 1, then Ray actor options should either be empty or we should set number of GPUs as 0. I will give the link to the issue and the sample in the description as well as in the blog for further knowledge. And here is the zip file that is present in the Docker image. Then the Hugging Face model ID, setting pipeline parallelism to 2 to shard the model between two workers, and then the model name which we are going to use for inference. Before hitting enter, let's port forward the Ray serve API which is running on 8265 port in our head service. So this is the head service, and in the head service we are port forwarding 8265. Um, hmm. So now we are ready to send our payload to Ray serve and uh, okay, yeah, send. Let's see the dashboard. It is available at the same port that we port forwarded. And here you can see that our application is under deployment. It will take some time, so let's wait for it to complete.
So now our application is healthy. As you can see, it took around 6 to 7 minutes. It's time to test our inference finally. And let's port forward the 8000 port from head service here. So this is the endpoint that we have already seen in the Docker image code, and this is the same that we have passed at a deployment payload and a simple content hello. Let's see what happens. Okay, it took around 2.29 seconds, and we have here a think token as well. Now let's ask some difficult questions that requires thinking. Here it's a simple question though, but I am prompting it to think and answer. This time it took a longer, but here's our answer, and it also generated a large amount of tokens as well. Let us look at the result. So yeah, let us look at the think token. I need to determine which, or I'll start by understanding that a shape has 6 is known as XLR. Next I will consider the specific example and angle may vary. I'll think about the characteristic whether on an instance of the shape have 5 sides and octagon has 8 sides. So hexagon is in between 3. It makes sense that it has 6 sides. Okay, that's interesting. Let us see where the think token has finished. Yes, here. So okay, I think that's it for this video. In this video, we ran a DeepSeek-R1 32 billion model on 2 Tesla T4 in a distributed fashion. So total we had 32 GB of VRAM, and we also saw how easy it is to do distributed workload using Ray, and we used vLLM for our inferencing engine. So in future I will make more videos about Ray and how we can use it for other use it with other inferencing engines as well. So thank you for watching and stay knowledgeable. Bye.